Hello everybody, today we're going to look at writing the equation of a circle, and the idea for what we're doing here today is if we are given a graph and our circle has a center somewhere, anywhere on the graph, let's say here, and that center is a point HK. We use these letters because it just stays consistent with some other things that we also graph. If you might remember parabolas in vertex form, we had y minus k equals a times x minus h squared, and the hk was our vertex there. Well, here in a circle, the hk is the center of our circle. And then we have the radius, so we can use any radius r. And if I were trying to graph this, I could go from our center over here and I could go up however many spaces r is, and that would be 1 point on my circle. I could go to the left the same distance, however many spaces r is, and that would be another point on my circle. And then I could go down that many spaces, r, there's r, and then I could go over to the right that many spaces as well. And there would be 4 points on our circle. And then to sketch our circle, we could just connect those points the best we can to make a circle. And we'll be graphing these as well, but I'll be focusing today on writing the equation. So what does our equation look like? Well, first of all, we have an x and a y, just like we did with equations of lines and exponentials and parabolas last year. But since the x coordinate of our center is h, in the parentheses with the h, we have an x minus h squared. And then it's plus y minus the y coordinate of our center, which is k. And then that gets squared, and that equals r squared. And you might recognize from our distance formula yesterday, we had x2 minus x1 squared, those two x coordinates, plus the y2 minus y1 squared. And the main difference is that when it equaled d, this whole left side was square rooted. But if we squared both sides, we would see something very similar to the equation of our circle. So how do we actually write the equations? Well, let's look at a couple examples, okay? First of all, if our center is the point 5, 2, I'm going to start by putting the x and the y in the equation first in the parentheses. Then I take the h from our center, and I'm going to put it in here with the x. I take the k, or the y coordinate of our center, and I put that in here with the y. And then I take the r, and it's on the other side of the equation, and that's got to get squared. So my final equation then would be x minus 5 squared plus y minus 2 squared equal to 7 squared, which is 49. So that's our first example. If I wanted to look at another one, this second one has a couple things that we want to watch out for that could pose us some problem. You'll notice that our center has an h of -3 and a k of 4. And the r is this thing in simplest radical form, 2 radical 5. So let's look at a couple of things here that could pose a little issue. Again, we'll put our x and our y in the form, and we have to do x minus h. Well, since h is negative, I have an x minus a -3. And just like in our distance formula yesterday, we want to simplify that double negative, and that's going to look like x plus 3 squared. Then in the second set of parentheses, we've got a y minus 4, and that one's pretty simple. We just have a y minus 4 squared. But then with our radius, the radius is 2 radical 5. And you can do this on your calculator or you can do it by hand, but when I square 2 radical 5, it's 2 radical 5 times 2 radical 5. And 2 times 2 is 4. But when I do radical 5 times radical 5, a radical 5 squared is just 5, and I have 4 times 5, which is 20. So this whole thing is going to equal 20. That's the r squared, okay? That's our r squared. Now, what you notice here, I want you to notice a pattern here. Obviously, the r gets squared, but notice a pattern in the center and what you see in the equation, okay? When I see x minus 5, the h is a positive 5. When I see a y minus 2, the k is a positive 2. All right. Down here, when I see x plus 3, the h is minus 3. And when I see a y minus 4, the k is plus 4. So in our center, when you put it into the equation, because of the subtraction symbols in the equation of our circle, what you see in the equation ends up being the opposite of h and the opposite of k. So let's look at one additional element here that can pose a little bit of a challenge, and that is when we're not told what the radius is, but instead we need to find the radius. And there's two ways you can find the radius. So first of all, let's start out looking at number 3 here. It says the center is 4, -7. So again, there's our h and our k. And I'm going to start by plugging these things in. We have x minus 4 and y minus a -7 that are both squared and added together. So the left side of our equation is done. X minus 4 squared plus minus a -7. We have y plus 7 squared. The question, though, is what is the r squared? Well, one of the things that we can do, if we take this equation with the unknown r and we use the 5 and the 3 from this other point on the circle as the x and y, that will allow us to solve the equation. Let's look at how this works. We're going to plug in the point 5, 3 into our equation. So let's look at what that would look like. Our original equation was x minus 4, and since the x coordinate is 5, I'm going to replace that with the 5. And originally I had a y plus 7 squared. Well, now I'm going to make that 3 plus 7 because that's my y coordinate. Okay, so we have our x coordinate 5 plugged in and our y coordinate 3 plugged in. And this whole thing is going to equal r squared. Okay, now one thing that's cool about this is that all I have to do is simplify on the left side. And because r squared is what's going into the equation, once I simplify the left side, I don't even need to take the square root like we did with the distance formula yesterday. We can simply do 1 squared plus 10 squared, and that's 1 plus 100, and get r squared equal to 101. And because r squared is what our equation requires, I'm going to just take that and substitute that in. So our final equation is x minus 4 squared plus y plus 7 squared equals 101. So that's one option. And honestly, I think that's kind of the simplest option. But there is another option. Here, we can just use our distance formula that we learned yesterday. In this case, notice the original problem. I've got x minus an h and y minus a k. They both have to be squared. But notice it says our center is at the origin. Well, that's our point 0, 0. So I'm going to substitute in a 0 as my h and a 0 as the k. in my equation. And the nice thing with this, when I simplify it, x minus 0 is x, so that's just x squared. And y minus 0 is y, so that turns out to just be y squared. And now I just need to figure out what the r squared is. Okay, so we can use our distance formula, and that distance formula, which was x2 minus x1 squared plus y2 minus y1 squared. And we use that point, negative 5, 2, along with our center point, because in the circle, if this is 0, 0, negative 5, 2 might be somewhere around here. Negative 5, 2, and there's our 0, 0. This is going to give us the radius. That distance right there is going to give us the radius. So that's the distance we're finding. So if I start by looking at my x coordinates are negative 5 and 0. And my y coordinates are 2 and 0. And I subtract each of those. I end up with a negative 5 squared plus a 2 squared. So that is the square root of 25 plus 4, which is the square root of 29. Now that's going to be the distance, but remember our distance is the radius in this case. So the radius is the square root of 29, but our equation requires us to use r squared. So that means I need to square both sides of this equation, and that'll get me r squared equal to just 29. And that 29 is what's going to go into our equation. So the final equation of this circle would be x squared plus y squared equals 29. So a couple of things as you go to practice here on the back. Remember, first of all, your general form, or your standard form, we call it, of the equation, x minus h squared plus y minus k squared equals r squared. So remember, each of these points is an h and a k that you're going to substitute in, and each of these is an r that you need to square. You might even go ahead and do the squaring part right over here. Okay, if the radius is 4, r squared would be 16, and so on. Okay, and then you're just writing your equation for each of these. Once you've got those down, then you can go ahead down here and try to find your r squared. Note what the center is, so you need to substitute that in first. And personally, I would recommend doing it the first way, like we did right up here on number 3. Substitute that point that you want your circle to go through for the x and the y after you've substituted in h and k already, and then once you simplify, that'll be your r squared. Okay, so hope this makes sense. And this isn't a terribly difficult thing if you just follow the steps and be careful. But give it your best shot, and we'll see how you do solving each of these and getting the equations of the circles.